Measures of dispersion. So take a minute just to read this information, write down what these units mean and the formulas. So you may want to pause it, and let's get started. Example 1 says find the indicated sum. When we have a summation of a lower bound of 1 and an upper bound of 3. So we're going to go 1, 2, 3. However, we are told what x1 is here. It's 2, and x2 is -2, and x3 is 9. So what we're going to do is plug in what we know. In this formula, we got xi minus 3 and squaring it. So this tells me that I'm going to take 2 minus 3 square, and I'm going to add it to -2 minus that 3 squared plus 9 minus 3 and squaring it. So now I got 2 minus 3 is -1 squared plus -2 minus 3 is -5 squared plus 9 minus 3 is 6 squared. So now I got -1 squared is 1, -5 squared is 25, and 6 squared is 36. So now I got 26 plus 36. This is equal to 62, and that is my answer. Okay. Number 2 says, consider the following set of ungrounded group or ungrouped sample data. A says find this mean and the standard deviation of the ungrouped data. So we're given this list of data here, and we're going to determine first what's the mean. Well, the mean says we're going to add them all up and then divide by the number of them. That formula looks like x bar is equal to the summation of n, where I is equal to 1 up to n. Xi, all divided by n. So I got 5 plus 9 plus 6 plus 6 plus 7 plus 7 plus 5 plus 4 plus 6 plus 8. And there is a total of 10 of these. So we're going to divide by 10. So when we add these all up and then divide, I get 6.3. Okay, so now I know the mean. Now let's do the standard deviation. The standard deviation is denoted at the square of the summation of I to 1 to n, where xi, so x from each one, meaning these here out of the group, minus my x bar, and we're going to square it, and then we're going to divide by n minus 1. So I'm going to write this down. Now you can actually do this on the side and then put them in there if you want, but I'm going to write it down. I'm going to try to write small if I can. So I'm going to have 5 minus 6.3 squared plus 9 minus 6.3 squared plus 6 minus 6.3 squared plus 6 minus 6.3 squared plus 7 minus 6.3 squared plus 7 minus 6.3 squared plus 5 minus 6.3 squared plus 6 minus 6.3 squared plus 6 minus 8. Oh, no, sorry. I apologize. I was trying to squeeze it in here, and it's looking kind of sloppy. So let me try it. So we were at what? 6 minus 6.3 squared. And then I'm going to add it to 8 minus 6.3 squared. And this is all divided by 10 minus 1. All right, we're almost there. So now that I know all this, I can say, okay, this gives me 1.69 plus 7.29 plus 0.09 plus 0.09 plus 0.49 plus 1.69 plus 5.29 plus 0.09 plus 2.89, and it's all divided by 9, right? Because 10 minus 1 is 9. So now we get the whole total number, divide it by 9, and we're going to have approximately, let's round to the nearest thousands, 1.494. So that's my standard deviation, and I got my, so this is my standard deviation, and this is my mean right here. So now that we've found that, let's go to part B. Part B says, what portion of this measurement lies within 1 standard deviation, lies within 2 standard deviations, lies within 3 standard deviations. So now let's solve for that. So to determine the proportion of the measurements that lies within 1 standard deviation, so I'm going to abbreviate 1 standard deviations. So we're going to take our mean that we solved above, and we're going to subtract it from 1 times that standard deviation that we got from above. And this gives us 4.806. Okay. So now I know, so that gave me, remember when we talk about standard deviation, we're going to be talking about normal curve. So now let's take, and let's add it, because we're going to find both sides of it. So when we add them together, now we get 7.794. So now when we go back up here to the data, so 4.8 and 7.79, we'll go up here to the data, and if we was to list these in a descending or ascending order, it doesn't matter. Let's make sure, oops, so there's 1, 2, 3, 7, 7. Oh, and there was 2 5s. 8, 9. All right. If we notice, because we came out with 4.806 to 7.794, if you notice, I have 1, 2, 3, 4, 5, 6, 7 that falls between those. Okay, between that interval there. So underneath the standard 1 deviation, we had 7 of them that fell within there. So I'm going to take that 7 and I'm going to subtract it from, or excuse me, divide it by 10. 1 second. Because I have a ratio, right? 7 to 10, there's a total of 10. So now I get this, multiply it by 100%, and I get 70% of the data from that group up there falls within the standard 1 deviation. So 70% of the data falls within that standard, that 1 standard deviation. Okay, so now let's solve for the 2 standard deviation. Well, we're going to take the same mean, we're going to subtract it, but 2 times that standard deviation. So when we do that, now we get 3.312, and then we're going to add it, because again, we're talking about both sides. So now when we add those together, we get 9.288. So I'm going to go back up here to determine that. Well, if you'll notice, that actually covers everything in the interval. So I'm going to have 10 out of 10, which is 1, and multiply it by 100%. This tells me that 100% of these data falls within that, within the 2 standard deviations. So let's solve for 3 standard deviation. So I'm going to take the same mean, subtract it from 3 times my standard deviation. And when I do that, Well, since 2, actually, it covered everything. I know that this one's going to 2, but we can still do it. 6.3 minus 3 times at 1.494. So now I get what, 1.81, and then we're going to add it. And we get 10.782. So again, this one's 100% as well. So now on part C, it wants to know, based on your answer to part B, would you conjure the histogram is approximate on the bell shape? So if we was to draw a histogram of it, if we was to put it on a graph, or you can create one in Word or Excel on it, we're going to get something kind of, my drawing is not that great. It's really not that tall. I made it too tall. So it depends on, so my drawing is going to be a little rough. Okay, so let's do it. We got 0, we got 2, we got 4, and we got 6. Now we got 0, 2, 4, 6, 8, 10. All right, so what happens at 4? We have 1. And then at 5, right here between 6 and 4, we have 2. And then at 6, we have 3. Oops. Then we have 1 at 7. Yeah, this is really what we need to do on the computer. And then 8, we have, 7, we had 2, 8, we have 1. And then we have 1 at 9. Okay, that's a really rough looking one, but you kind of get the idea. But looking at this, note that the bell shape curve is tailed to the center of the tape. So if we have, you notice we can draw the bell shaped curve. The center seems to have the highest peaks, kind of giving us an almost normal bell shaped curve. So since the data values fall near to the mean, with fewer data values further away from the mean, the histogram is approximately bell shaped. Okay, so my answer on C is going to be a bell shape. It's approximately close to a bell shape. I mean, it's because the data falls near to the mean. And 10 says to confirm what we came up with, to construct the histogram, the class of 1 with the wide 1 starting with 0.5. So we this is drawing it out right here. That's D. Okay. So example 3, standard deviation formula, and some information there. It says example 3, find the standard deviation for the set of group sample data. So what we're going to do, I'm going to go ahead and put another row here. This one's going to be called my midpoint, XI. And this is going to be something else. We'll get to it. So my midpoint formula is going to be upper bound minus lower bound, or excuse me, not minus, plus lower bound divided by 2, because there's 2 right here. So for the first one here, I'm going to take 0.5 plus 3.5 divided by 5. and I get 2. I'm going to take 3.5 plus 6.5 and add it by, or divide it by 2, and I get 5. 6.5 plus, and you can list the bigger number first if you want when you're adding. Divided by 6.5 plus 9.5 divided by 2 gives me 8. 9.5 plus 12.5 divided by 2 gives me 11. All right, so far so good. So I know what xi is. I found my midpoints. Now I want to find out what's my mean. Well, my mean is going to be the product of my midpoint times my frequency. So that is going to be where x bar is equal to the sum of k as my upper bound, I till 1 is my lower bound, all divided by n. All right, so formula is my midpoint times my frequency of the first group, dot, 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 to the last group, divided by frequency 1 plus frequency 2 plus dot, 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 out to the total frequencies. Okay, so we're going to add them all up. So on this first one, I'm going to take 2 times 4 plus 5 times 5 plus 5 times 8 plus 5 times 11, all divided by 4 plus 5 plus 5 plus 5. So now I get get 19 in the denominator. And then we get 8 plus 25 plus 40 plus 55. Let's add it all up. So we're going to round to approximately the nearest hundreds. We get 6.74. So that's my mean. All right, let's find our standard deviation then. So our standard deviation of this here is going to be the summation of upper bound k equals lower bound of I equals 1, x1 or xi minus x bar, the mean, squared times the frequency, all divided by n minus 1. Okay, so that's going to get, oh, and I got my mean. I should have multiplied these here together. If I would have done that, I would already had them. I could have just added them up. Okay, now let's finish this out. So I'm going to take from each of the F's. So looking back up here at our table here, I have 2 minus my 6.74 squared plus 5 minus 6.74 squared plus 8 minus 6.74 squared plus 11 minus 6.74 squared, all divided by, what do we have, 19 minus 1. All right, so that leaves me with 18, and double check my math. 2. I'm gonna just retype it back in my calculator. 6.74, yeah. 1 second, guys. Taking me some time to just double check. Okay. So I got 4, 5, 1, 2, 3, 0, 4. Now we're going to divide that by 18 and square root it. So my standard deviation and went around to nearest hundreds. And I want to kind of double check just to make sure that I agree with my answer. Okay, so give me 1 second. Let me type it one more time. I just want to double check. So what do we have? We had 2 minus 6.74 squared it plus 5 minus 6.74 squared plus 8 minus 6.74 squared plus 11 minus, what's 11? Minus 6.74 squared, all divided by 19 minus 1, which is 18. Yep, that's what I got. So that's my standard deviation. All right, let's do our next one then. Our next one says the earnings per share dollars for 12 companies selected at random from the list of Fortune 500 companies are. So you get this table here. And the first one says, find the mean of the earnings per share. So we're just going to take them all and add them all up because we're going to find the mean. So we got a bunch here. So if you don't want to write them down, you just want to type them in your calculator, just make sure that you write, don't transpose a number. It's easy to do. It is a lot of numbers here. And then we're going to divide by the number of them. So we got what, 1, 2, 3 rows, 1, 2, 3, 4, there's 12, right? Total of 12. So now let's take it and put in our calculator, 1.24. Well, or you could write on the side and do it on paper. That's always good to be able to calculate without having to depend on the calculator. I'm just doing it for the sake time. All right. And divided by 12. And I got $4.66 for my mean. Okay, now let's find our standard deviation. Our standard deviation is taking every one of these numbers again, all right? Because we're going to do xi minus x minus the mean, squaring it, all divided by n minus 1. All right, so that's going to be a lot of writing. So to save on time, I'm not going to write it in. We did one previous. Well, I mean, I can. Give me a second. Let me write it down right quick. Let's see if I can write small. I'm going to go dot, 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 and y'all get the idea. Go all the way out to the last one. And there was 12 minus 1. Okay. So I'm just going to type it all in my calculator, and I'm going to round to the nearest hundreds. Came out with $278. And that's it.